Alright, I'm going to explain how to do the problems for this maze. I'm not going to do all the problems, but I will do enough so that you should be able to do the rest of the problems. And remember, you are to show your work. So here we go. Let's start with this first box, which is number 1. And I'm going to take a look here and see that it is a right triangle, which means I can use a squared plus b squared equals c squared. Okay, and then I notice here, you always want to notice where the c is, the hypotenuse. Okay, the hypotenuse is here, and hypotenuse gets to be the variable c. So these other two can be interchangeable as a or b. The reason this side is the hypotenuse is it's because it's directly across from the right angle. And as a characteristic, it happens to be the longest side. But to identify it, you actually use the fact that it's the side across from the right angle. Okay, so now that I know that, I'm going to choose one, either 6 or 15 to be A. So I'll say 6 is A, not that it has to be, it could have been B. I substitute it in, so the A comes out, the 6 goes in, and I substitute B with 15, and I substitute C with x squared, or x, and then it's still squared. Okay, so now I'm going to square 6 and 15, so if I do, now hopefully you know 6 squared is 6 times 6, which is 36, or you can do 6 times 6 here, or you can press 6 squared, which is 36. So 36 plus 15 squared is 225 equals, and then I just rewrite the equals and rewrite the x squared. Now, since these two constants are on the same side, I can go ahead and combine those. So I already have 225 in my calculator. I'm going to add it with the 36. It's 261. Again, if it helps to circle, go ahead and see that they are on the same side, which means that they can actually be combined. And then I have an x squared. I'm almost to the end, so I need to get rid of the square by square rooting it, square root, and this cancels out. And then I'm going to have an approximately, because I'm going to have to round this 261. I'm going to take the square root, which is this yellow part right here. So to get to that, you press Shift x squared, which is 16.15549. I'm going to cut it off at the 1, but I want to round it, so this 5 tells that 1 to go up. So it'll be 16.2. So going over here, I see 16.2, so that will be leading me to my second problem. Okay, so number 2, I've got a right triangle, so I can use a squared plus b squared equals c squared. Okay? And then I need to identify what c is, because again, that's where a lot of students get mixed up. So c is here this time, because it's across from the right angle. And it's this, again, it's not a variable, so you'll have to be careful about that. Okay, so these are my a and b. So, all right, let's say I make the x my a. And then I put the b is the 4 squared equals, and then the 6 substitutes in for the c. Okay, so now in my next line, I'm just going to rewrite it with the 4 squared turning into 16 and 6 squared turning into 36, because 4 squared is 4 times 4, okay, which is 16. So I'm going to rewrite the x squared plus 16 equals, and then 6 squared, which is 36, okay? 6 squared, 36. Now notice I didn't press shift, because when you do shift, you're going to be taking the square root, which makes it smaller. Whereas when you square a number, it gets bigger. Yeah. So then I have a box, and I have a circle and a circle. Now when you have shapes or terms that are like terms that are on opposite sides of the equal sign, you have to do inverse operations to get them together. So you want to get the box, the variable to be isolated, okay? So you want this constant to go away from the variable. So you're going to subtract, inverse operation, subtract 16 to get rid of it. Whatever you do to one side, you do to the other side. So you have x squared equals 36 minus 16, so 36 subtract 16, or 36 plus 16 negative, okay, that's 20. And then get rid of the square by square rooting. Excuse that.
This time, all yearbook club students, please report back upstairs to the computer lab next to Mr. Kim's room. All yearbook club students, please come back upstairs to the lab next to Mr. Kim's room. Thank you.
Okay, so we're going to take the square root of 20. So we got to take the square root, so we're not going to just press x squared, we're going to press shift x squared, and that gives us 4.47. I'm going to round to the nearest tenth, which is where this 4 is. That 7 tells that 4 to go up, so 4.5. Okay, so if you look here, this is going to go up to the 4.5, and this one takes us to the third problem. Okay, I'll probably do about 5 problems total. So then, number 3, okay, we have the hypotenuse being here, which is x, okay, because it's across from the right angle. So I'm going to go ahead and do the Pythagorean theorem with this. So we have 19 squared, any of these could be a or b, plus 18 squared equals x squared, because the x is in the hypotenuse spot. So 19 squared, that's going to be a big number. So let's see, 19, and just square it. That's 361. And then 18 squared is 324 equals x squared. Now these can be combined together. They're on the same side, so you add them. So I already have a 324. I'm going to add it with the 361. You get 685 equals x squared. Square root both sides. Okay, so on the right side you have an x. On the left side I'm going to be rounding, so I'm going to use the approximation symbol. Now square rooting, you have to press shift x squared. And I want to round to the nearest tenth, so that 7 tells it to go up, 26.2. So 26.2 is my answer here. I'm going this way, and this will be my 4th problem. Okay, so then I go to number 4. Okay, and number 4, we have 7 squared. Well, okay, before I do that, identify which one is the hypotenuse. Okay, the hypotenuse happens to be over here across from the right angle, and it's x, so that'll be our c. These could be a or b. So I'm going to write a squared plus b squared equals c squared. Okay, and we have 7 squared, I'll use that as my a, and the 9 squared. The a doesn't have to be the smaller number every time, and I could have put 9 here and 7 here. Whoops, sorry, can't see my work. So what I was saying is you can put the 7 here or the 9 here, and it would still be the same answer. So you can interchange a and b, but the c has to be in the right spot. So x is x squared here. Now 7 squared is 49, so 7 squared, or 7 times 7, okay, same thing, 49. Hopefully you know that 9 squared is 81. Okay, I'm going to combine those, the 49 plus the 81, and that's 130. So 130 equals x squared. Okay, square root the x squared, square root 130, and you get x is approximately equal to 130. Square root that, it's 11.4. And the reason it stayed 11.4 is because the 0 tells the 4 to stay, so it doesn't go up. Okay, and 11.4 is taking us in this direction, so I'm now at this problem. Now here, some students have a hard time saying, well, where's the hypotenuse, and they want to turn. You can. If you want to turn the picture, then you can see it better. Okay, that's absolutely fine. Or you can just notice that, hey, here's a right angle, so it's directly across from it. So 27 is your hypotenuse. This is your C. So that means these are going to be your A and B. All right, so that's my problem number 5. And let's say I decide A is going to be my 9. So let me write it first. A squared plus B squared equals C squared. And then A, let's say I'm going to make that 9. And then I'll put the X here. And then the C is the 27 squared. Okay? So 9 squared is 81 plus X squared equals, okay, I don't know what that is, 27 squared, 729. Now this is interesting. So I have a circle, box, circle, and I have a circle on both sides. The question is, should I move the 729 by subtracting that, or should I move the 81 by subtracting that? I would, either one is mathematically allowed. However, I would probably move the 81, get it away from the variable, so that the variable is by itself. So subtract 81, that's the inverse operation. Whatever you do to one side, you do to the other side. These eliminate, cancel. You bring down your x squared, rewrite your equals. Go ahead and do 729, I already have that, minus 81, and that's 648. Okay, and then you square root and square root. This is going to be x. Whoops, that's an approximation. Square root that, shift x squared. Now this 25.4, the 5 tells the 4 to go up, so it'll be 25.5. Alright, so let's see, where's the 25.5? It's right here. Okay? And I think you should be able to do the rest of these. So I'm going to stop here. If you have any questions, feel free to text until maybe 8 o'clock tonight. And yeah, or why don't you call a friend and ask them, and or review back on your notes or review back on one of these videos, because all of these problems that I've done basically explain all the problems that you need to know. Okay.